How are you doing today? Welcome. This is, welcome to Technical Debt. I am Andrea Soper, and I have a card that tells me who I am. I am Zen Doodles in all the lands. I am less active than I used to be, but member of the Core Mentor program, helped set that up. Also a sprint organizer and mid-camp planner, and I'm a senior engineer at Palantir.net. Hi. Yes, go on.
Yeah. I'm Joe Purcell. I'm also an engineer at Palantir. I've been part of the web development community since 2003. I'm someone who's inspired by the discoveries being made from cross-disciplinary research, and I enjoy adventure. Palantir is a full-service agency. We do design, strategy, and development. And we're active in the open source technology community. So,
that's who we are. Now, who are you? You are developers, you're project managers, or stakeholders in projects, and you kind of want to know what this technical debt thing is all about and what you can do about it. If that doesn't sound like who you are, it's okay to leave now. We won't be angry. So technical debt, what we're going to be talking about is how I don't even remember why we have this slide up here.
Okay,
I'm just going to move on.
Yeah, totally fine. Here we go. So before we begin, I'm going to tell a short story. The story is about smog. So smog was a term coined in London, not in LA. This is an image here of London during the 1800s when it was so smoggy, sometimes people couldn't even see their feet. There was so much smog in the air. What would happen is the Thames River had fog that would come in through London, and it would combine with all of the smoke from chimneys and factories. At the time was the Industrial Revolution, which was being built on cheap energy, which at the time was coal. Coal would burn and create this yellowish, greenish smoke that would combine with the fog, and they would call it pea soup fog. So if you heard the term thick as pea soup, that's what it's referring to. So this went on for decades, and people just coped with it. There was even the peppered moth. By 1800, at that time, there were almost no dark-colored peppered moths. They were almost all light-colored. By the end of the 1800s, so about 1900, it was the complete opposite. There were almost no light-colored moths. So they had adapted where those that were light-colored would be more apparent to predators, and so they were thinned out. People would put detonators on train tracks. So when a train is coming into the station, they would hear the detonators go off so they know a station is approaching. Sometimes they would have to cancel events that were outdoor because the smog was so thick. But all in all, people just coped because at the time to be against smog and to promote regulation to mitigate that was to be against progress, because you were being against the primary source of energy for the Industrial Revolution. So in 1952, it was December, and there was a sharp cold spell, and people were burning an abnormal amount of coal, combined with what's called an anticyclone event, where the air basically stood still around London. So smog accumulated over the course of 4 days, and within weeks, there were 4,000 people that died. It was the worst air pollution tragedy in London's history. But it was also one of the most critical points in environmental change. Some would say that it inspired the modern-day environmental movement. It was regarded as a division between the thinking that progress produces pollution. So pollution is just a natural outcome of industrial advancement. It was a change between that paradigm of thinking And any progress that does not regulate pollution is no progress at all. So change wasn't immediate after this. There was a committee that formed to investigate the issue. They started with, what are the symptoms? So they see illness. You know, people are coughing, they get pneumonia, etc., and transit problems. So you can't see. So, you know, I mentioned the detonators on trains. Sometimes there were even car wrecks because visibility was so low. So what were the causes? Well, it was pretty straightforward. Anything that would cause this greenish yellow smoke or just dark smoke, they would point to that and say, okay, that's where this smoke is coming from. And in 1956, they passed the Clean Air Act. So they said, what are policies that we can do to mitigate this problem? And they started using clean energy like electricity or burning gas. They increased the height of chimneys, and they moved industries out of the city. So what does all of this have to do with what we're going to talk about today? Well, two ways. One is that we believe the monetary analogy that's used with technical debt communicates the wrong idea about how we measure technical debt and how it impacts business. Secondly, we're going to use the same approach. So we're going to talk about symptoms. We're going to talk about what is it that we're actually describing when we say technical debt. Second, we'll talk about what are the causes of it. And lastly, we'll talk about some policies and practices that we can use to mitigate against technical debt. So, first section, what is technical debt? Well, let's go back to the original context. Ward Cunningham, he was working with Wyatt Industries, writing software for financial software, and he was trying to describe what they were doing on their development team. What they were doing is they would start with a prototype, and they would iterate over it over time, because at the time the market was changing, and their clients' needs were changing very rapidly. So they would take their current understanding, they would build something, deploy it, with the expectation that they would change it later. So he says this. This is how he described it to his boss. Again, this is a financial context here. He says, shipping first-time code is like going into debt. A little debt speeds up development, so long as it's paid back promptly with a rewrite. See, the idea here is that you can delay effort, you can defer effort to a future time in order to meet a short-term objective. One example might be to shorten the time to market. So in this case, they're wanting to shorten the time to get feedback from the clients about changes they're making. This might be also known as failing fast. Another example would be preserving startup capital. So say you're a startup, you have a limited budget. You might want to defer features to a future time, so you intentionally leave out certain functionality. This is good, right? It's good in the same sense that taking out a loan is good. So instead of having to save up for a house, you can take a loan out and buy a house right now. But there's a danger here. So the danger occurs when the debt is not repaid. Every minute that you spend on not quite right code counts as interest on that debt. What he's saying here is that, in the monetary analogy, is that as you're accumulating more debt, you're also accumulating interest payments. So your future income is being reduced because you're taking on more interest. Here are two examples where this might be a problem on a team. One is where the feature effort, if you have a feature that you need to complete, pushes back a deadline. That's bad, right? Another example is if you have a bug. Say you have some kind of product and a bug is found, but you have so much technical debt and not quite right code in your system that the amount of effort to fix it is longer than an SLA that you've agreed to with your clients. This is bad. So there's a lot of disagreement about what not quite right code is. Ward and others like him tend towards an ideal approach where they say, all right, look, you're a professional, write clean code. You should never have bad code introduced into the system. But Martin Fowler takes a little bit more of a pragmatic approach. He asked the question, does debt describe what we're referring to? So instead of nitpicky about, this is technical debt, that's not, let's take a step back here and think about, okay, debt as analogy, does whatever we're talking about apply to this analogy? So he came up with this 4 quadrants. On the right side, you see prudent. Prudent is what Ward and his team were talking about. So they're prudent programmers. They're always writing correct code, but on the top end, you have deliberate and prudent. So this is an example where, yeah, they might ship code that is missing a feature with the expectation of doing it down the road. So they might cut a corner. Maybe you abstract a class with the intention of turning it into a concrete class when you have more time. But there's also inadvertent technical debt that you introduce. That's on the bottom right. So in this case, maybe you introduce code with certain assumptions that you've made about your user's needs, about what the system is, and it turns out to be wrong. You discover what you actually need is something different. An example of this is prototyping. Also, Agile is very prone to this section of technical debt because it's all about evolution. You want to deploy code and iterate over it as you go. On the left side, we see reckless. So let's talk about the top left. So reckless and deliberate is the worst kind. This should never happen. Basically, this means that you are deliberately introducing wrong code into your system. But we as developers, sometimes we have certain pressures. Maybe you're just really tired and you just throw code over the wall, or maybe there's pressure on the team to get something done and you do something knowing that it's incorrect. And anti-patterns might fall into here. So the bottom left, you have inadvertent reckless code. This happens when perhaps you have a developer on your team who is very novice. Maybe they don't know how to use design patterns. Maybe they're not familiar with coding standards. Maybe they're not familiar with best practices of the framework. So they're writing code that's not quite right for integrity of the system, and they're not being intentional about it. But this is all these things combined, when we say not quite right code, might fall into one of these 4 categories. So what is the effect of having technical debt in your system over time? Robert Martin has a book called Clean Code, highly recommend it. He has a diagram in there, and he's talking about, in his context, he's talking about the cost of maintaining a mess over time. It also applies here. You're talking about owning technical debt or not quite right code over time. As time increases, your productivity goes down. Because what happens? So at the start, you can spend 100% of your effort on writing new features because there's nothing to struggle with in your system. But as you introduce technical debt, you introduce things that need to change. Maybe you're copying and pasting a lot of code. Your productivity declines because you're spending time working on paying down interest on your technical debt. Notice that Brooks' law applies here. If you throw more people at this problem, it doesn't resolve it. In fact, it makes it worse. Because as you take someone onto the team, you need someone to train them. Assuming you don't train them, then they're going to be writing code not knowing if the code they're writing maintains the integrity of the system or not. So the fact is, debt has to be repaid. So how can we think about technical debt in the context of other effort that we do on projects? Philippe Cruchten gave a talk on this idea of what color is your backlog. And I love this idea. So we're going to talk about these different quadrants and what they are, and frame technical debt and effort on technical debt within the context of these other types of efforts. So top left, you see visible positive value work. So these are features, right? So a client says, I want a login system, right? This has positive value. It's something that they need for the software to work for their business objectives. And it's visible. Everyone sees that login system. But in order to have a login system, you need something invisible known as architecture. That's on the top right. Sometimes you might actually put this into a backlog as like an engineering ticket. Sometimes you put architectural effort wrapped into an estimation on a feature itself. But in any case, when we're looking at a backlog, you have to include both of these. Both of those are required for the application to work. Now let's look at the bottom left. So these are bugs. It's negative value, which means that effort spent here is not actually, it's not of positive value to the organization. It's stuff that should have already been done, but it's visible. So everyone sees that, you know, when I type a space into the username input and it fails to log me in, or maybe that's not a good example, but bugs are something that everyone sees, and usually with a ticketing system, you identify this as effort that needs to be done. So here's where technical debt fits in the bottom right. So these are things that are not quite right, so it's negative value, and it's invisible. This is why it often gets overlooked. Technical debt is something that often gets overlooked or set aside on a project because it's something that, unless someone who understands from the architecture and the code point of view, they won't have visibility over this effort that needs to be done. One of the things that we need to be proactively doing, implied by this, is that we need to expose and manage technical debt in the same way that we're exposing and managing these other types of effort. So here's where we think that the monetary analogy communicates the wrong idea. Is technical debt a single metric type of effort? No. Monetary debt is. We have a number that describes I'm $1,000 in debt. That's one metric. But with technical debt, there is no single metric. Is it easy to measure? No. You can log into an account, say your bank, and see readily how much debt that you have with that organization. You can't do that with technical debt. Is it constant and deterministic in terms of its impact? No. So with monetary debt, we have scheduled payments. We know we can even calculate our pay down of monetary debt. And it's constant. It doesn't vary over time. That's not true of technical debt. Here is where the pollution analogy communicates the right idea. Is pollution multi-metric? Yes. When you want to think about air pollution, you can't just think of smog produced from burning coal. You also have to think of automobiles, etc. Is it difficult to measure? Sure. If you want to measure, if you want to build a tool to measure radiation, you probably want to have a PhD in physics or chemistry, maybe both. Is it variable and probabilistic in terms of its impact? Yes. You don't know when a contaminant in an environment will end up being a problem for your city. So let's say there was a factory that shut down and there's chemicals in that factory. It is very hard to predict when that's going to become a problem. The same with technical debt. There might be code that's not quite right. You may not touch it for 3 months. And when you have to touch it, you don't have some clear metric that says this is the impact on your system. Managing your code is more like a garden than a bank account. When we were talking about London smog, you don't just default on the environment. And you can't just take out a loan and pay off all of the pollution that's in the environment. It takes time, just like a garden.
So now we kind of understand a little bit about what technical debt is and what we believe technical debt is. But how did we get here? What caused all of this debt? Where did we get into a pollution state? This is where we feel like the Lorax analogy really shines. I'm assuming not everyone has read the Lorax recently or seen the movie, so I'm just going to kind of go into the story a little bit. In the Lorax, the Onceler came to where the land where the grass is still green, the pond is still wet, the clouds are still clean, and the swami swans sing into the space or something like that. So he comes along these truffula trees, and they're beautiful trees, and they have these great tufts of silky silk things that he then harvests and makes a thneed, because a thneed's a thing that everyone needs. And in order to do that, he chops down this tree, and he makes it, and makes the thneed. And from the stump, where the thneed was from the tree, the truffula tree, comes this Lorax, who is shortish and mossy, and his voice was sharpish and bossy. And he jumps out and he says, I'm the Lorax and I speak for the trees. And we feel like it's really important for there to be a Lorax who speaks for the code as well. Eventually, the Onceler chops down nuts trees and he calls it hacking. And then he gets a multi-axe hacker, which he gets out and chops many trees at once until he has run the brown barbaloots and their barbaloot suits off, and the humming fish are no longer able to swim in the pond because it's all gummed up. It's a gluppity-glup with the gluppity-glup. And and the swami swans had to go away too. And this is what happens when the technical debt is accumulated. So so then the Onceler says, because the Lorax, he's all there all the time saying, no, you can't do this. I'm the Lorax, I speak for the trees have no tongue. And so the Onceler says, and for your information, you Lorax, I'm figuring on biggering and biggering and biggering, turning more truffula trees into thneeds, which everyone needs. So maybe we can make some analogies on our own, but I'm going to totally tell you how to think about that. So the Onceler had some schedule pressures, right, and was introducing schedule pressures. The thneeds couldn't be produced fast enough. In the story, he even brings in more of the Onceler family to knit these thneeds, and because you have to make them, because that's, business is business, and business must grow, regardless of crummies and tummies, So when we think about what kinds of pressures introduce debt into our project, one of the biggest ones is, let's get it done faster. It's got to be done. And so we ship code before it's ready, right? And maybe we even ship code when no one else has even looked at it, right? Because it's got to go in fast. There's also the business pressures. Sure, we can totally make a thneed. You mean you want pink? I don't even know if they make it in pink, but yeah, absolutely, let's have a pink thneed. Or an orange one. Do do truffula trees come in orange? I don't know. I don't care. We'll do it. And so these are the kinds of business pressures that the Onceler can put on your team to make us, as the Lorax, have to do things that we don't want to do. Also, changing requirements. This is a fun and interesting thing. So Agile is great and does some interesting, but it does some interesting things. If you build a bicycle, which we've talked about in other formats, like if you build a bicycle, in order to make a race car, there are going to have to be changes, right? But Agile promotes this idea of you're not going to need all that stuff. You're not going to need it. So we build this bicycle, and then the next sprint comes along, and they're like, "What do you mean you have to replace the tires? We just built those tires. We can't do that, or you need a bigger body. That's crazy pants. We just put the frame on there." And so when the requirements change, and you're not going to need it, this is another thing that introduces technical debt into your project. The code practices. So one of the biggest indicators of technical debt would be code complexity. When you have very complex code that no one understands, that takes a new developer 2 weeks to just onboard and know where anything is. And there's, here is a really good indication. If it's going to take 2 weeks to onboard a new developer, and that new developer is still not going to be able to touch certain pieces of your project, it's a pretty good indication that probably there were some problems on there. Not having a good style guide or style, there's a word for this, we have it in the Drupal, the coding style, yeah, having code style documentation and code standards. Not having a good, not being able to reuse design patterns also introduces technical debt, or technical pollution, as the case may be. Incomplete or non-existent tests. Testable code, shocker, testable code is good code and clean code typically. Writing tests that writing tests forces us to think about our code in a different way, and it makes us write clean code much better. Also, incomplete documentation kind of falls a little bit under this because tests often count as our documentation as well. If another developer can't come in and work on the code, it's probably not documented very well, and possibly, maybe, has some technical debt in there. So I repeat, cried the Lorax, I speak for the trees, for the trees have no tongue. So these are the things that we think are kind of important to keep in mind. However, how do I deal with this technical debt? It's important to note that the things that cause it, all of those things that we were just talking about, wait, let me look at my cards. Incomplete tests, business pressures, and schedule pressures, like taking those away don't necessarily mean that you're going to not have technical debt. So how do we deal with technical debt going forward? You will never be so good that you don't have technical debt, right? And sometimes, like Joe was saying, sometimes technical debt is good, right? Sometimes it just makes the most sense, and you're never going to touch it again anyway, and it's just, that bicycle is plenty.
So one practice or one aspect of an organization that can mitigate against technical debt is culture. Specifically about culture is being green from a technical standpoint, so building an environment that promotes clean code. When it comes to environmentally being green, it applies that it requires everyone to be on board, especially leadership. At Palantir, we have, it's kind of neat, all the furniture that we have is from zero-emission factories. Some of the dividers in the office are made from recycled buttons. We have recycling. We have a bike shed where someone who wants to bike to work can hang their bike. The whole culture, the whole office.
And a shower, in case you do
yes,
want to bike.
because you will get hot and sweaty biking
right.
in Chicago.
Also, a garden?
Yes, and we have garden, which is great. All of these things combine to making it very easy to be green. And that starts with leadership. I mean, they enabled all of this to happen. So the reason this is important to have leadership backing your green efforts or your clean code efforts is because when you're trying to communicate invisible negative value to a client, you will need that backing. You will need that support from your whole organization. BDD language communicates business requirements without the business pressure. If any of you have looked at Gherkin, hopefully you have an idea of what I mean here. Gherkin is a way to describe what the client is needing in a standardized format. It keeps it formal. If you have a client coming to you and they're in a panic because they have some new deadline that they need to meet, or they have a client who has, so maybe they're working with another organization and they have something that has changed on their end, and they're under pressure. As perfectionists, as people who are focusing on writing clean code, it does not help to have all of that pressure, all of the business pressure added on to you. Using behavioral language is a way in which you can effectively communicate across your whole organization what is needed in a fashion that's formal and doesn't have the business pressure that's attached. Project managers, you need a Lorax, and you need to support your Lorax. You need to be able to allow a Lorax to come in and pull the andon cord and stop the conveyor belt and say, this is something that we have to address now.
What kind of cord?
Andon, is that right? The Toyota's andon cord, which is mentioned in the keynote.
Right.
Which is, if you learn at the keynote, the andon cord, it's Toyota implemented a pull cord along the entire factory conveyor belt that anyone could pull at any time if they noticed a defect in what was being made. So the whole factory would stop to address the problem. The alternative was they would let the defect be built into a full car that would get marked as a defect car. They would come back to it later, completely deconstruct the car, fix the problem, and put it back together. This stops the problems at the source.
But the key is you have the person who comes to respond to the cord has to thank the person to hold the cord. That has to be appreciated rather than, oh no, that person screwed us up and slowed us all down.
Exactly, and as Mark was saying for the recording, the key is you have to thank the person who's reporting the defect, as opposed to the Ford culture at the same time, which we talked about actually we didn't talk about that this time, but the Ford culture at the same time would actually punish the person who pushed the big red button and said stop.
Yeah, because you need more needs.
Right.
Everyone is needing them.
Everyone needs.
But support the Lorax. This is how the culture has to support clean code. Protect the focus of your team. Project managers play a key role in this. Focus is positively correlated with quality. If your team can't focus on writing good, clean code and really thinking through the problem space, they're not going to be able to avoid technical debt, which will imply that over time your productivity is going to decline and clients or your organization won't be able to get what they wanted in the first place.
Design patterns. So a design pattern is a known, repeatable code which demonstrates low or no technical debt. So these are things that are just repeatable. Some people that are smarter than me have implemented this pattern, and I can reuse it in other places. Knowing how to reuse these patterns and teaching your team to reuse these design patterns is very important in the elimination of technical debt. Also, having, as we talked about before, having good code standards and style standards as well are part of that design pattern and recognizing quality code when it's there.
Plan to refactor. We hinted at this earlier, but Agile is prone to technical debt because of Yagni. When you're under the mindset of don't build something until you need it, it is very easy to fall into a place where you're introducing technical debt intentionally because you're trying to meet the end of the sprint. You want to complete a story.
What is Yagni?
Yes, for those who don't know Yagni, you ain't gonna need it. It was extreme programming practice by the same group of people as Ward Cunningham, etc. In Cruchton's presentation, so this is back to the what color is your backlog, he asked the question, is architecture and Agile, are they like oil and water? I thought that was an interesting question to ask. There is a tension here between you are starting with a bicycle, you're starting with an initial design, but in the end you need to build a race car. You want to avoid the big upfront design like waterfall, but in the end you need a race car. bicycle and race car have very different requirements in terms of the architecture, in terms of the system that you're building. So there's a trade-off here. Bufty, big upfront design versus being able to pivot. So please, plan to refactor. One way to do this is building into your development cycle. So Ward Cunningham even suggested an excellent time to refactor is right before you extend it. Well, when do you extend it? If you're doing Agile, that's going to be in between sprints, right? So in between features that you're working on. Another way to approach this might be to build refactor time into your estimates on features.
Test-driven development. Well, we talked a little bit about behavior-driven development, which is using the proper language to get your requirements from your stakeholders. Test-driven development means that we write our code. We don't write our code until after a test has been written. It helps us to think about the way that our code will be implemented, and it turns out that, like I said before, quality code, testable code are one and the same. IBM and Microsoft did a study together, and it was several years ago, and they found that implementing test-driven development had increased the amount of initial development time by 15 to 35%. So about 1 day a week you're going to spend on test-driven development. But it decreased the defect density of the products released between 40 and 90%. So that means that the quality of the code at the end of the project was going to be 40 to 90% better. This improves your development time and decreases your code debt, your technical debt, your pollution. See, words are hard.
Continuous integration is another way in which you can stop technical debt, technical pollution at the source. Using the analogy of coal, burning coal, you can use coal scrubbers. In our case, what does this look like? This could be configuring your IDE to throw errors when you are incorrectly, when you have a code style violation. You could use Git hooks, so pre-commit hook. So you can't even commit code unless you fix certain errors. You can also use a continuous integration system to send these alerts when you push code and the build, quote, build will run, and any violations of whatever metrics are using to identify technical debt can send an error. One way to do that would be with Travis. So define quality and the tolerance level of the pollution that you'll allow. I recommend going to phpqatools.org and phpmetrics.org. But I'm going to go through a couple different ways in which, a couple different PHP tools that identify different forms of technical debt. One is PHP CS. This is a code style violation detector. Another is PHP DCD. This detects dead code. Dead code means that there's code that's written that, according to an interpreter and the rules that it has, believes that your system is not using this code at all. PHP CPD, so this is detecting when you have copy and pasted code, which the reason that's bad is that's an indication of, here's a case where, okay, if you need a third one, you have to yet again copy the code. Well, good, clean code eliminates duplication. So that's a symptom of you're doing something wrong. It's not quite right code. pdepend, this is a detector for cyclomatic complexity. The single best tool that I've found personally has been PHP mess detector, PHPMD. It'll detect it defines certain thresholds, and this is why it's kind of controversial. So for example, by default, you can only have 100 lines in a method on a class. There's certain limitations to the length of a name for a method, a class name, etc. I have found every time that PHP mess detector has thrown an error, I've usually been able to find an abstraction or some change that I can make to make the code better. So there are cases where, practically speaking, you can't agree to all of PHPMD's terms, but it's a good starting point, and I recommend it. Find what the tolerance level is. Maybe it's 150 lines instead of 100, because maybe you're introducing it halfway through development on a project. There are other tools you can use, like Code Climate will take all of the metrics that it has, consolidate all of that into a GPA. This represents the quality level of your code base. So you could adopt on your team, you could say, all right, we're not going to drop below 3.5. If we do, we're going to stop everything we're doing, we're going to pull the and-on cord, and we're going to fix whatever the problem is. It also works on a per pull request level, so you could deny merging a pull request until those quality issues are fixed. Same as CI Scrutinizer also has a GPA metric you can use.
Speaking of pull requests, someone has to review that code. Now the test spot has passed, and you know, the PHPMD is happy, and Travis is thumbs up, and all the things are good. But someone needs to go in there and review your code. This is really important, not only from a perspective of you know, your local Lorax, making sure that code doesn't pollute your code base. That's bad, but also to ensure that your developers are also continuously improving and learning things from the process. We, as a code reviewer, I learn things. As a reviewee, as a person who is whose code is being reviewed, I always learn something. So it's a teaching process. It's a Lorax. It's the goalkeeper in the soccer game. Code review is the last thing before that pollution can get into the pond, and that's the final stop for it. Oh. And this is where that slide was supposed to be. Because unless someone like you cares a whole awful lot, nothing is going to get better. It's not. This is the quote from the Lorax. And actually, no, this one is actually the Onceler, who at the end of the story, as I was saying, is telling his story to a young boy. And he says, I've figured it out, because, you know, the Lorax disappeared once all of the trees were gone. But he figured out why the Lorax left the stump that said unless. And unless someone like you cares a whole awful lot, nothing is going to get better. It's not. If we don't have a Lorax on the team, if there's no one to speak up and say, hey, this code shouldn't ship, then nothing is going to get better. And you're going to continue to have a code base that is polluted and difficult to work in. Do you have more to say about that? Okay. Questions?
Questions are good. Yes.
So does that mean that every team needs a single Lorax, or does that mean that every person needs to have a little bit of Lorax in them?
Yes.
Yeah.
So here's the thing. Here's the thing that's really important about the Lorax, and that is that your stakeholders, they don't know what good code looks like, right? So somebody has to stand up and say, look, here's a problem, this is a problem. And so if you're the one looking at code, then yeah, sorry, you're going to have to channel your inner Lorax in order to say, hey, I speak for the trees. Because your stakeholder doesn't know, right? He can't see the code. Or he could see the code, but he wouldn't know what he was looking at. Otherwise, he wouldn't have hired you, right?
There's actually a moment in the Lorax story where it says something to the effect of, you never know what anyone will buy. And there's a photo of this guy wearing a thneed, and he just looks ridiculous. The same goes with code. I mean, people who don't have visibility over the code and can't understand what it actually, like to determine what's right code and what's not quite right code, I mean, people will buy anything. So I think it speaks to not only us as developers, but to businesses in general. I mean, if you're going to buy software, if you're going to pay thousands of dollars to buy software, how do you know that it's actually good quality code? So I think it speaks to them as well that, hey, the Lorax is something to say here. Every time you're putting that pressure on your team to deliver early, we need more and more and more, I'm going to bigger my business, think about the Lorax and think about, yes, here's the image. What does he say?
You poor
here?
stupid guy, you never can tell what some people will buy.
Which is silly and fun.
Right,
but,
yeah, well.
I mean, I guess all in all, I just wanted to say that yes to us as individuals, developers, yes to having a leader on the team who's really speaking up, but also, look, businesses, like, you also need to be promoting. It has to be from the top down, leadership in the organization on the software team to leadership on the organization buying the software.
More questions?
So should we just start calling this technical pollution everywhere? Like,
Yes.
all agree?
And then you should put a TM after it, and we'll trademark it, and that's totally us. We did that.
Technical pollution by Palantir.
Wait a minute.
Maybe we did that.
I was actually thinking about, should we position part of the talk to be about, let's use technical pollution, but I figured, all right, we'll just, because some people may not be familiar with technical debt, so let's just let's get the idea started.
Wait for the book.
Steve.
Book right there.
Oh, yes, the book is already written for us.
In one of those diagrams you had, I think, technical debt and architecture in different quadrants of the negative values below
The invisible.
the positive, and the positive values above of features that have not yet been built and architecture that has not yet been built. In that diagram, the stuff above the line, the positive stuff, is stuff that doesn't exist yet. The stuff below the line is stuff that does exist currently. If you have a given element like, say, Drupal's, you could frame it either as Drupal 7's use of globals all over the place. You could frame that as technical debt, or you could frame it as a lack of an architecture that allows for an alternative. How do you know when to categorize something as existing technical debt or architecture that just hasn't been built yet?
How do you know when something is a feature and when it's a bug?
If it's desired or not. It's a feature if you can simply close the issue and say, yeah, this is what we want, we're not doing anything. It's a bug if it's going to result in a patch. Getting rid of globals, Drupal 7 to Drupal 8, that's a big patch. Is it a patch that introduces architecture, or is it a patch that solves technical debt?
So
Yes.
I think the answer is yes. Yes.
My point is, I think the answer is yes, but my point is, how do I use this board if I don't know which category to put something in?
Well, I think that, in my opinion, when the globals were introduced, that was not necessarily considered an architectural problem. We learned things, and we learned new ways. So that was the case of it was a bicycle, and now we need a race car, and things have to be changed, right?
Yeah.
That we needed to plan in refactoring. So it wasn't necessarily debt yet, although arguably there are people in the room that might argue with that. It wasn't necessarily debt yet, but if we continue down that path, it certainly is, right? Because it was a thing that needed to be refactored in order to use.
Yeah.
I think Larry may have things to say in that regard.
Well, just to kind of echo what you're saying there, something can start out as desirable and become undesirable as business needs change. The existence of technical debt does not mean someone screwed up. It means this is not what it should be for what we're trying to do with it.
Okay.
Something can start off as a feature that you added specifically as a feature and realize, oh, everybody hates this. Now it's a bug. We should take it back out.
Okay, so in the case of globals, globals were the architecture. That was the point. That from anywhere you can grab everything. And that's the architecture, that's the point. And as expectation shifts,
I think it puts, like, over time then, it becomes that technical debt category.
So maybe technical debt is architecture that you don't want anymore.
Like weeds.
Well,
Right?
in the slide.
Yeah.
Now we know we should have done. Like,
Yeah.
Yeah.
Right, right.
Yeah,
Well,
so-
and
and-
when if we go back to the gardening analogy, you know, you have to cultivate good code, which also means you got to pull the weeds, right? You have to, you know, cultivate the good code and pull out the not so good code, right? And a weed is only a weed because you don't want it anymore. It may have been like mint. I really wanted mint. Maybe I didn't want it over there. But if you're planting mint, it's going to get over there. So yeah, it's one of those things.
If you start using globals, they're going to globals are going to be global.
Right.
So, like, maybe another way to, like, bugs are flaws in the features that you want right now, and technical pollution are flaws in the architecture that we want right now. Good architecture helps to make feature creation easier. Technical pollution makes it easier to create bugs.
Yes.
Very well said.
Absolutely. Can you
Fiona,
repeat that?
can you
So
repeat
for the
that
microphone?
for the recording? Make
Yeah, I wish I could.
Say it slower. Say it slower.
Well, I was thinking about how these interrelate, and that bugs could be considered flaws in the features that we want right now.
Okay,
Because
wait.
you
Let
already
Andrea say that.
Okay, so bugs are considered flaws in the features that we want right now. And also, architecture facilitates the implementation of features, right? And technical debt facilitates the implementation of bugs.
Right. And technical debt are flaws in the architecture
Right
that they
now.
want.
Right.
That we want right now.
That you have right now.
You have, but you have.
That we have right now.
Yeah, just like bugs are flaws
Well,
in the features that you have right now. Like,
That we desire.
well,
No.
because if you have a bug in a feature that you desire but don't have,
It's not really.
it's not really
It's still a feature.
it's still a feature. It's not. I don't think it's a bug until you build it. Like if you
That's why-
specifically plan a not yet built feature, knowing it's going to have a bug,
That seems like
then you're planning to introduce
that's
technical.
bad architecture is what that is.
Oh, maybe.
Or poorly defined business requirements. Well, I mean, right?
Yeah.
Yes.
I always thought technical debt was, I wrote a line of code, I have to maintain one more line of code, I have increased my debt. Is that not the case? Because if I write a good line of code, then I'm not really incurring any debt.
Yeah, that's a whole other conversation about, is code a liability for an organization or is it an asset, right? And that conversation is different than the context of what technical debt is. So the question is like writing a line of code, it's one more line of code to maintain and therefore debt for the organization because you're having to maintain it, right? That's the question.
Yeah.
So
And it's
that's a
also
different.
that's an interesting thing as a possible cause of technical debt because there are still systems where you're rewarded for more lines of code, right?
Yep. So that's where, like with PHP it does have limits of how many lines are allowed in a file or a method. So yes, that lines of code can be an indicator of technical debt, and that it's
Or complexity.
in complexity.
That was a different
Yeah.
conversation. What's the terminology for that conversation?
So my initial thinking about is code an asset or is it a liability? I think of it in terms of is a house asset or is it a liability? If your focus is on cash flow, then a house is a liability. But if your focus is on wealth, an asset, house is an asset. With code,
It's more like a boat.
I don't know where that would tie in. It wouldn't tie into technical debt.
I think it depends on if you're a service organization or if you're producing a product, right? If you're producing a product, then your code is an asset.
If you're using the code as an asset, if you're supporting the code, it's a liability.
There you go.
Well, I think I think it comes down to what your objectives are, right? Like back to the house being an asset or liability. If it's cash flow, that you're after, so with code, what are you after? If you're after maximizing effort on new features, then code might be a liability. Existing code is a liability because you have to maintain it. But if your focus is on curating the code you have, it might be an asset. I don't know. I think it's a good conversation to have.
Great conversation.
And I'll be honest, I don't have a good answer for it. So
I think to have that conversation, you need a point of comparison. So for the case of a house, specifically from the cash flow perspective, it's hard to call it an asset or a liability unless you have something to compare against. If your mortgage is low and the rent market is ridiculous, then your house is better than renting, and the reverse could be true. With the line of code, is it an asset or a liability compared to what? Like that line of code does something. Is it a net asset or liability compared to what alternative? If your alternative is, I don't know, managing your content in Google Docs instead of Drupal, I'd say that then Drupal is a net asset probably, because I think it's an easier way to manage content than Google Docs. But if we're comparing it against, I don't know.
But that depends on the requirements
imaginary
too, right?
Drupal 9, then maybe Drupal 7 is a liability.
It also depends on the requirements. It could be the case that in some cases, Google Docs is the best place to
That's
manage
true.
your content. So it's a really complex discussion, which, as you said, environmental discussions are hard and complex. Yeah.
Well, I just mean where I've heard that argument before is like in terms of time, or in terms of like cognitive load, which I guess you're kind of talking about here. But it's, because I don't quite have a full thought.
yeah, one of the things about the monetary analogy is people immediately want to make comparisons between code and time. Because you can do that with debt, right? You can compare, well, I have an income of this much, I know how long it's going to take me to pay it off. Right. So from a business perspective, I think if you're trying to compare time and code, you're using the wrong frame of mind. Like it's more similar to pollution. Yes, I think you should try to find some connection there between time and code, because that information is valuable. But when you do it, it's not simple. Like it's complex. It's non-deterministic. And we're still developing the tools to figure out what the connection is.
Well, if you're just looking at the time involved, then all code really will be a liability.
Yes.
It has no other, it's all bad, because it all takes time.
But in comparison to what? Does it take more time than what alternative?
Then sticks and stones?
Accomplishing something. Right. Like, how else are you going to accomplish that?
I don't think it accounts for that.
Yeah.
This was fascinating and really good presentation.
Thank you.
Thank you.
Thank you. We would like feedback, but they're not doing.
Oh, did you do it joined in?
They didn't do that for this event.
You can make it joined in.
I can make
tweet
it
out a link or something.
Oh, cool.
What's the reference?
Yeah, so we'll post the slides. We have a list of references that were used during the presentation.
And we actually have a few more.
And there's also some recommended reading. We'll post this up. We recommend reading all of this.
I'll put them on Twitter and they'll tweet it.
Yes. We'll tweet the links. We could mention a few of the major ones. Mythical Man Month by Fred Brooks. Highly recommend that. Andrea has been all about clean code.
Yeah, that was great. Is that on there?
Robert Martin.
It's on.
Philippe Christian's presentation on what colors your backlog is really cool. There's some clever things in there.
I do not see the one for the IBM study.
Oh no, yeah, we don't have the IBM study in here.
Yeah.
We'll add that.
Yeah, I have a couple to add
Yeah.
because my index cards don't
Oh.
translate well to.
If you are wanting to make a comparison between code and money, there's a book, it's Software by the Numbers. I highly recommend this, not because I've read it, but because I read someone's review of it, and what they were describing sounds like there's a lot of solid material in this book if you're wanting to actually crunch some numbers around how to compare them. So that's Software by Numbers by Mark Dene and Jane. Yes, last name.
Cleland Hogg.
Huh?
Huang?
Yeah.
Huang.
Wow. Cleveland Hall. Okay.
This is not the kind I want to talk about.
Are we good?
All right, we're going to hold you to that.
All right.
promise.